So today's topic is what? Ionic compounds or electrovalent compounds. So yesterday we have seen how do metals and non-metals react with each other. So metals react with and non-metals react with each other by transferring and gaining of electrons, where metal transfer the electrons to the non-metal and non-metals gain their electrons, and itself they become positive and negatively charged, and they together form a compound, and that compound we call it as a ionic compounds or electrovalent compounds. So the definition of the ionic compounds, or it is also called electrovalent compounds, it is the compounds that are formed by the transfer of electrons from a metal to a non-metal. That means the transferring of electrons which takes place from the metal to the non-metal and form a compound, the compounds that are known as what? Ionic compound or electrovalent compound. So in this case, some examples are given. NaCl, sodium chloride. So sodium chloride here, the sodium transfer one electrons to the chlorine and itself becomes sodium anion, cation, and chlorine after gaining one electron it becomes chloride anion. And since both become positive charge and negative charge, oppositely charged, so they form a force of attraction, and that force of attraction is known as electrostatic force. Electrostatic force. And in the other example, magnesium chloride, where the magnesium transfer its two electrons to two chlorine and become magnesium chloride. And the other examples are potassium chloride, where potassium transfer one electrons to the chlorine and it becomes chloride anion. And since both are oppositely charged, positive and negative, so they form a compound. And other example it is calcium oxide. So here calcium is the metal and oxygen is the non-metal. So calcium transfer two electrons to the oxygen and becomes the positively charged, and oxygen after gaining two electrons it becomes negatively charged. So since due to the oppositely charged they form a compound. And the other example it is calcium chloride. So here the calcium loses two electrons. It gives two electrons to the chlorine, where there is two chlorine. Each chlorine gains one electrons, and due to the oppositely charged, positive and negative, they form a compound, and the name of the compound it is calcium chloride. So there are many more examples are there. So next we have to know the properties of this ionic compound. So what are the properties of ionic compounds? And this topic is very much important for your SSLC examination. Properties of ionic compounds. So there are mainly four physical. So also remember that the property here it is physical property, not a chemical property. So it is physical property of ionic compound. Physical nature. The first property is about the physical nature. Second property we will be discussing about their melting point and boiling point. And third property we will be discussing about the solubility. And fourth property we will be discussing about the conduction of electricity. Okay. So physical nature. So let us see whether the ionic compounds are solid, liquid or gas. As we know that NaCl, which we commonly use at home as common salt, Namak. So it is a solid. So therefore physical nature becomes the ionic compounds are solid. They are solid and hard. They are very much hard also. The reason is also mentioned here why they are hard, because of the strong force of attraction between the positive and negative ions. Okay? Because of the oppositely charged, they form a strong force of attraction and therefore the ionic compounds are solid and hard. So this is the first property which is necessary. So that is, ionic compounds are solid and hard. Why they are solid and hard? Because of strong force of attraction. Next, it is about melting point and boiling point. The ionic compounds, they have very much high melting point and boiling point. Okay? When we melt the ionic compounds from solid to liquid, it requires a very high temperature, or very huge amount of heat is required to change their state. Okay? Some temperature is given in your book on the page number 48. So 48 page number, table 3.4, you can see the melting and boiling point of some ionic compounds. So NaCl, the melting point, it is 1074 Kelvin. Okay? It is given in the assignment. Again, the boiling point, it is 1686 Kelvin. That is approximately around 1412 or 10 degree Celsius. Okay? 1400 approximately. And next is lithium chloride. So lithium chloride, its melting point, it is 887, approximately 600 degrees Celsius. And the boiling point, it is 1600 Kelvin. So that means approximately it should be 1350 degree Celsius. And calcium chloride, whose melting point is 1045 and boiling point it is 1900. And other melting point and boiling point is also given in the book. Those are calcium oxide, magnesium chloride. Yes or no? So their melting point and boiling points are given. As we can see, the melting point and boiling point, it is very much high. So why they have very much high melting point and boiling point? So this question is asked mostly in the HSLC about the melting point and boiling point. And you can also come to the page number 49. Question number 2. Why do ionic compounds have high melting points? The reason is already given here. Ionic compounds have high melting and boiling point because a huge amount of energy, that is heat, is required to break the strong interionic attraction, interionic force of attractions. So that is, interionic means oppositely charged ions. So why? Because a huge amount of heat is required. So next topic point is about the solubility, whether they are soluble or not. As we can see, ionic compounds are generally soluble in water. They are soluble, easily soluble in water. So when we take the salt and mix it in the water, it gets completely mixed. Yes or no? So that means ionic compounds are soluble in water. But point to be remembered, it is they are insoluble in solvents. Okay? Solvents like example kerosene, petrol. Okay? They are insoluble in kerosene and petrol. How much you try to mix it in the kerosene and petrol, the ionic compounds will never get mixed. Okay? They are insoluble. And conduction of electricity. If we talk about the ionic compounds can conduct electricity or not, so here it is given. Ionic compounds do not conduct electricity. Ionic compounds, they basically do not conduct electricity in solid state. This point you should remember. So ionic compounds, they do not conduct electricity when they are in the solid state, but it can conduct electricity only in molten state. But it can conduct electricity only in molten state. So what is molten state? So molten state is the liquid state. Okay? When we heat the solid and it becomes liquid, that liquid state is known as a molten state. So ionic compounds, they can conduct electricity only in molten state. So sometimes it also asks, why do the ionic compounds they conduct electricity in molten state? The reason is given here. This is due to the electrostatic forces of attraction between the oppositely charged ions are overcome due to the heat, and ions are moved freely and conduct electricity. So when we heat the ionic compounds and it becomes molten state, then due to the huge amount of heat, when it comes to the liquid state, then the ions which are present, they becomes free to move, and this free movement of ions conduct the electricity. So these 4 points are very much important. The physical nature, ionic compounds are solid and hard, melting points and boiling point. Ionic compounds have high melting point and boiling point. Solubility, ionic compounds are soluble in water and insoluble in solvent. Conduction of electricity, ionic compounds do not conduct electricity in solid state but conduct electricity in molten state. So note it down. You have noted down. So our next topic is occurrence of metal. So how do metals occur?